In this section, we will examine basic diagnostics and will be using the indicator lights as our guide. Remember that all faults must be cleared by cycling the remote switch or the service switch before any diagnosis can be performed. Make sure you note which fault is on the circuit board display before turning off the remote switch. Power on indicates that the service switch on the side of the circuit box is on and the board is powered up. The furnace is ready to run. The power on light may be accompanied by the red remote open light. This indicates that the interior remote function switch is off and is not a fault. Turning on the remote turns off the red light on the board. If it does not go off, check the telephone cord connections. Burner on indicates that the system has had a call for heat, either from a thermostat zone or from the WW position. When the burner on light comes on, the bottom green light, pump on, will light, indicating that the system circulation pump is running. At the same time, the combustion air fan starts and the igniter begins to glow, followed in about 10 seconds by the furnace. If the power on light is on and a thermostat is turned up and the burner on light does not come on, follow this procedure. With the thermostat turned up, check the zone terminal, T1, 2, 3, and 4, to see if voltage is present, and check the corresponding fan zone, F1, 2, 3, and 4, for voltage. If voltage is present at these positions and the furnace is cold, go to the 9-pin connector underneath the lights and bridge positions number 3 and 4, the 2 green wires. These are the operating aquastat positions. Keep your bridge in place until the furnace fires. If it does fire, check and replace the operating aquastat. Ignition fault. The ignition fault light will indicate a short in the ignition circuit. The ignition fault may indicate either board replacement or igniter problems. Compressor fault. This fault indicates that the compressor is drawing too many amps. This fault may be accompanied by the blow-and fuse fault. This will be the fuse marked main. Remove the compressor and verify excessive amp draw. The compressor should draw approximately 4.5 amps and produce approximately 9 to 11 pounds of air pressure when connected to the nozzle. Replace the compressor. Air fan fault. As with the compressor, this fault indicates that the combustion air fan is drawing too much amperage and may be accompanied by the blow and fuse fault. Replace the air fan motor. Water pump fault. This fault indicates a short circuit and will be accompanied by a blow and fuse fault. The fuse is marked pump. Check the reason for the short circuit. High limit fault. This fault is the result of over-temperature of the furnace fluid, generally caused by poor or no circulation. Check the pump fuse and that the pump is running when a thermostat is calling for heat. Next, check the level of fluid in the expansion tank and top up as necessary. The tank should be full and the overflow tank should have 2 inches in it when the furnace is cold. Turn on the circulation pump and look for agitation in the expansion tank. If there is no agitation, then the pump may be undersized, or there may be restrictions or an airlock in the piping. Ignition flameout fault. This fault is the result when the furnace fails to start after the second attempt and is the result of a component failure or no fuel. First, confirm that the furnace is going through the standard start sequence by observing the air fan running, the igniter glowing, and the compressor starting. If the air fan can be heard and the air is coming out of the exhaust and the igniter pin is glowing, shut down the furnace using the service switch on the side of the circuit box. Take off the front cover and remove the fuel block assembly intact. Ground the fuel block assembly and point the nozzle at a cloth or into a container, making sure to aim it away from the igniter and that you can see the nozzle. Turn the furnace on, confirm the proper operation of the igniter and the combustion air fan, and see if the nozzle emits air and fuel when the compressor comes on. If there is air present but no fuel, confirm that the fuel solenoid is opening by stopping and starting the furnace, listening for the click of the solenoid operation. Remember, the fuel block assembly must be grounded. Confirm that the fuel pump is operating by opening the bleeder valve while the startup sequence is underway and watching for fuel coming out of the bleeder and listening for the accelerated pulse of the pump. Remember that the pump pulses approximately once per second in normal operation. If there is no air coming from the nozzle, there can be no fuel, and we can conclude that the compressor has failed. The photodiode can also cause ignition flameout. If the unit starts up and runs briefly, but if the ignition flameout comes on before the unit shuts down, it can be a bad photodiode or connections. Run flameout fault. This fault involves either fuel or the photodiode. In the fuel-related fault, the furnace will be running normally and the flame will go out, accompanied by white smoke from the exhaust. The white smoke is the result of unburned diesel fuel coming in contact with a red-hot combustion tube. The flame has gone out because of air in the fuel. Reset the fault, and while opening the bleeder valve, start the furnace. Observe whether air bubbles emerge from the bleeder orifice. Continue to bleed the furnace until only diesel emerges from the orifice. Shut the valve. You may have to restart the furnace 1 or 2 times using the service switch, clearing the air from the fuel system without going through the bleeding procedure. In the photodiode-related fault, first confirm that the problem is not fuel. Then place the furnace in bypass mode and start it. Measure the voltages at the photodiode test point, watching for fluctuating voltage staying well above 1.5 volts. Observe the appearance of the flame. A blue flame color indicates a lean running condition and indicates either a dirty nozzle, a fuel solenoid that is partially closed, or a restricted fuel filter. In general, a furnace that will run in bypass but faults when taken out of bypass has either a defective photodiode or a defective circuit board. It is important to remember that the furnace circuit board is sensitive to improper installation, exposing it to excessive AC voltage interference. If this condition is suspected, please call the technical helpline listed in the owner's manual. Voltage fault. The Hurricane furnace is designed to operate on voltages from 10.5 to 15 volts DC. The furnace will fault outside of these voltages. Typically, low voltage is the result of deeply discharged batteries or improper wiring techniques. High voltage is usually the result of an overcharge from a battery charger's initial charge phase. A low voltage fault needs to be reset. A high voltage fault will automatically reset when the voltage reduces. Blown fuse fault. This fault refers to the fuses on the main circuit board. Replace the fuse and check for normal operation. Remote open. This is a result of turning off the remote switch. Remember, if the furnace faults, do not turn off the remote switch until you have determined what fault is shutting down the furnace. The Hurricane furnace is a very safe device, and it is safe to leave the switch on until the fault has been confirmed. Bypass on. The bypass light is on any time the furnace is in bypass mode. In addition, the red light on the remote switch will blink. Never allow the furnace to run unattended in bypass mode. Pump on indicates that the circulation pump is energized.